So when we do a hypothesis test, we talked about this in our lecture time, there's only two decisions we make, right? Just like it's a very similar concept to our justice system. You have a null hypothesis, right? And in our justice system, we assume that this defendant, they walk into the courtroom, we are assuming they're innocent. They sit down there. Hopefully, juries are not making any judgments on the person. In a lot of ways, that's the great thing about our justice system. We assume they're innocent, and then if we are overwhelmed by evidence that the prosecution presents, the defense doesn't have to provide any evidence. It's not their job to show that they're innocent. We assume they're innocent. And whatever evidence the prosecution brings, we would have to be overwhelmed by that. So when we do a hypothesis test, there are only two things that we might do. If we are overwhelmed by the sample statistic in this case, right, this X bar, the p hat that we get, if it falls so far from the null hypothesis, then we reject the null hypothesis, okay? Or we fail to reject the null hypothesis. So think about a court case. There might be evidence that a particular defendant was guilty, right? There might be evidence of that, but it wasn't enough. So it wasn't that the defense proved, it wasn't that you accepted the alternate hypothesis. It wasn't that you accepted their innocence. You had to assume it to begin with. It wasn't that you were ever convinced that the alternate hypothesis was true. We're not doing that. You just weren't overwhelmed enough to reject the null. So we either reject the null hypothesis or we fail to reject the null hypothesis. Okay. Next one I want to jump to conceptually is question 5. So this talks about the idea of the p-value, and I gave you sort of a mantra in class to deal with the p-value, and this is why I think the hypothesis test is, I don't want to say easier or it's just a cleaner, more straightforward tool, okay, in terms of making a statistical inference. So what the p-value means is we have our null hypothesis living here, and it depends if it's a one-tailed, two-tailed test, or right-tailed, left-tailed rather, or two-tailed. But wherever we get our test statistic, right, whether it's z or t, this is the p-value. So this is the probability, this area down here that you've been dealing with for a while. It's the probability of the result occurring if this is true. So if this is really small, then we're going to believe, well, it's possible that this is true. It's like any defendant that's like, well, all of this evidence was made up, and the video that they showed and the 3 eyewitnesses, they all lied, and it was a big conspiracy. We could say, well, that's possible, but it's really unlikely, right? It's and then we would reject their claim of innocence, right? So that's what the p-value means. It's the probability that we would get that result if the null hypothesis was true. It makes it hard for us to believe that the null hypothesis is true, so we choose not to believe it. That's our decision. So a large p-value will favor rejection of the null. That's false, okay? A small p-value, right? And this is the mantra I gave you in class. I said, if the p-value is low, the null must go. If that makes it easier for you to remember that, if the p-value is low, the null must go. Might make that rule easy for you. So a lot of my students like that. Okay. So here we have a particular claim. It doesn't say whether it's a null or an alternate, but I have to say this would have to be a null. What I explained in class is that the null hypothesis always has some incarnation of an equal sign. Usually when I teach this, it's always an equal sign. It makes life so much easier. But the null could be a greater than or equal to. The null could be a less than or equal to. Or the null could be an equal to. You won't see anything else in the null. So as soon as you see an equal to bar here, you know that's a null hypothesis. Null means no difference, which is equal to. So anything containing an equal to situation is the null hypothesis. So the alternate to that, if mu is greater than or equal to 382, the only alternate to that would be that mu would be greater than 382. Right? We need the two cases to be mutually exclusive. No potential overlaps. Oops. Sorry about that. I clicked on the wrong button. So less than, right? So you got greater than or equal to 382. The alternate to that would be less than. Okay. Alright, so find the complement of the claim, which is the null and which is the alternate. So This is like I explained before. The null would have to be that first statement they gave us, 38 greater than or equal to 382, which A looks like it has, but its alternate is wrong. So I'm just going to scan through here and find the one that matches what I want. I think it's C, greater than or equal to 382, and then less than 382 for our alternate. Looks good. Okay, so now we have a two-tailed situation. When this comes up, okay, I'll jump to my canvas here. When we have a not equal to situation, here's our null hypothesis, then that means our result could live out here, or it could live out here. It could be either one of those. That's a not equal to. So one of the things that we want to be careful of here, the p-value sort of doubles. So if I get a p-value, like if I'm only going to get one test statistic. I can't get a statistic that lives in two different places at the same time. It's impossible. But if I get one out here, and let's say this p-value out here is 0.03, well, then I have to consider that it could have happened out here as well. So if it's a two-tailed test, if my alternate is a not equal to, then my p-value would be 0.06. I'd have to double that. Okay? So use the given and write the complement. So the complement of this claim would be that sigma equals 7. And we didn't do anything with sigmas this week. That'll come next week. But we'll do hypothesis tests for them just like we did confidence intervals. So that's the complement, right? Now, which one is the null and which one's the alternate? Remember, like we said, the null is always going to be an equal sign, okay? The alternate would be your not equal to. I think we're squared away on that one. First one that popped up there. Okay, so let me jump to number 12. Null and alternate hypotheses are given. Determine whether the hypothesis test is left-tailed, right-tailed, or two-tailed. Okay, so what we mean by that is this. We got our null. He always lives in the middle. Okay. You know, suppose somebody is saying that, you know, the true average weight of a box of, you know, cereal is such and such, and somebody else comes along and says, no, I think it's actually less than that. Okay? That's a left-tail test. They're trying to say that something is less than what's actually claimed. If somebody comes along and says, no, I think the, you know, true average weight of a player on such and such a team is higher than what you're claiming, that's a right-tail test. If somebody comes along, that's terrible. If somebody comes along and says, I just think what you're saying is not true. Okay, maybe you have like specifications on a manufacturing machine and it needs to be accurate within a certain amount. Well, then it doesn't matter, like say making guitars, it doesn't matter if the guitar is tuned too low or it's tuned too high. It's going to be a problem either way. That's a two-tailed test. Okay, so that's what we mean by left-tailed, right-tailed, or two-tailed. So some of this is going to be our reading comprehension, but here we just have the symbols. So the null here says that p is less than or equal to 0.8. So let's think about what that means. So here's 0.8. That's the null hypothesis. If p is less than or equal to it, anything to the left here, out here, everything's good with the world if this happens. That's the null hypothesis. Generally, I'd like to say p equals 0.8. But if p is less than or equal to 0.8, everything's good with the world. Nobody cares. It's not going to impress us. The alternate is where we'll have a problem if p is greater than 0.8. But we know from working with statistics that if p hat lands here, or p hat lands here, or p hat lands here, that's not remarkable. That's not going to cause us to think that 0.8 is untrue. Now, if we get something out here, if we get a p hat that lives out here, that's where we would reject that p equals 0.8. That's why this is called a right-tailed test. Look at where that significant value would have to live. Okay, it's right-tailed. So if the alternate's a greater than symbol, it's a right-tailed test. If it's a less than symbol, it's a left-tailed test. And if it's not equal to, it's a two-tailed test. Okay. And last one we'll look at. So here I have sigma less than 2.5, greater than 2.5. That's going to be another right-tailed test.